This is part 2 of section 1.7. So I said in the end of the last video that I was going to end up repeating myself, and here we are. This is exactly what I had written. F inverse and F undo each other. So if you plug in X to one and then take that answer and plug it into the other, you get X no matter what. One of the things you're going to be asked to do a few times is to verify that two things are inverses, and you're going to need to do this check. First, let's look at this, just for understanding our concepts. So if we have f of x is equal to x cubed, we're asked to find the following. F of 2, okay, so that would be 2 cubed, which is 8. Okay, f inverse of 8. We haven't yet talked about how to change this into the inverse function, but this is about a concept. If I plugged in 2 and I got 8, I plugged in 2 and I got 8, now I should be able to take this 8 and plug it into the inverse and get 2 again. Okay? Now if you look here, this is f of f inverse of 15. F of f inverse of 15 is 15. And then this one is the same. It's just f inverse of f of 27. The order of these don't matter in this case because it works in both directions, so this is 27. Okay. So let's show that these functions, f and g, are inverses of each other. And we do that by verifying that f of g of x and g of f of x, which we know are not generally speaking the same, but they need to both give me x, or it is not a function. So let's do f of g of x. Well, that would be 2 minus 3 times g, 2 minus x over 3. Your 3's cancel. Distribute the negative. 2 minus 2 plus x, which is x. So that direction works out. Now let's do g of f of x. So this would be 2 minus f, and I need to use parentheses because there's a minus, so 2 minus 3x over 3. So this is 2 minus 2 plus 3x over 3. The 2's cancel, then the 3 does, and you get x, and these are inverses. Okay? With this problem, we want to do essentially the same thing, except on this one, even though technically you should go in both directions, I'm only going to go in one because I want you to see how these things can be complicated to check and to figure out how to do it. So I'm just going to do f of g of x. The other direction will work very similarly. Okay? So this will be 3 times x plus 2 over x minus 3 plus 2 over x plus 2 over x minus 3 minus 1. Okay, I'm going to do a quick rewrite of these, a little bit of a grouping, so it's a little bit easier to see what's going to be happening here. So I can rewrite this as 3 times x plus 2 over x minus 3 plus 2 over x plus 2 over x minus 3 minus 1. Now I'm going to multiply the top of my main fraction by x minus 3. So I'm going to be multiplying all of this by x minus 3, and all of this also by x minus 3. When I distribute this is going to cancel out that denominator. So I have just 3 times x plus 2 plus 2 times x minus 3. Over, and then the same thing happens here. This cancels this denominator. So I'll have x plus 2 minus 1 times x minus 3. So it's still an ugly fraction, but at least it's not fractions within fractions. So now distribute, and I have 3x plus 6 plus 2x minus 6 over x plus 2 minus x plus 3. So I have 5x over 5, which is x. The other direction will be similar. Just be careful with it, and you can do it.